Good afternoon, everyone. I'm happy to see you all join this session. And this session, we are going to talk about big data easy BI. We are planning to go production in next quarter. And we are from Yahoo Taiwan e-commerce data team. And my name is Tim Xu. I'm a senior data engineer at Yahoo, and I focus on data modeling and BI application design in data team. And my teammate, Neil Lee, is also here. He is a Hadoop data engineer in our team. Our goal is to build up an easy-to-use BI platform and a self-service BI application for our e-commerce end users. So welcome here. And in this session, I will start by give you a background introduction about us and why do we need to create such platform for our e-commerce users. And then I will give you a quick view of our solution we proposed to our end users and give you a quick demonstration using this platform. Okay, let's get started. And who are we? As I said, we are from Yahoo Taiwan e-commerce data team. And you probably know that there is a global data team in Yahoo headquarters just right here in Sunnyvale. And why there is a dedicated data team for e-commerce in Taiwan, such a small country, right? And why the Yahoo global data team cannot do these things for Taiwan users. Okay, before I answer this question, we have to know more about e-commerce business in Yahoo Taiwan. Let me just give you some facts. You probably know that Yahoo actually runs media business, advertisements business in most of the regions in worldwide. But Yahoo runs e-commerce business in Asia Pacific, and Asia Pacific it just happened to be the best region where Yahoo runs, in the few regions where Yahoo runs e-commerce business. And in Taiwan, we have three major e-commerce properties, which include three major different type of business model of e-commerce. The first one is Yahoo Auction, started in 2011, which is a C2C model. And you can see that Yahoo Auction is a kind of eBay in Taiwan. And the second property is a Yahoo Shopping Mall. We started in 2004, and we Yahoo, own this platform, and we managing all the products, we manage the transactions, and we manage the logistics on our own. So we sell the products and provide the service to our consumers. And the third one is the Yahoo Store Market, started in 2008. And this is a B2C2C model, which means Yahoo run the platform for sellers. And sellers can go to this platform to open their online shopping site and then manage their products on their own. They manage the logistics on their own, but we provide transactional and some kind of payment service for the sellers. Okay, these are our property we run in Taiwan. And actually, because of these three different e-commerce properties, which makes Taiwan e-commerce so unique, so valuable to Yahoo worldwide. And in the chart in the right-hand side, you can see that in 2011, actually, Yahoo e-commerce is the top 7 vendor within all the retailers in Taiwan. And among of them, there are only 3 vendors running e-commerce business. The rest of the retailers in this chart are traditional retailers such as convenience store, department store, and even some wholesale stores. Okay, let's get back to the question. Why there is a dedicated data team in e-commerce in Taiwan? Why the global data team in Yahoo cannot do analytic reports for our end users? That is because the business only runs in Taiwan, And the core mission of Yahoo Global Data Team is to create a generic data platform and create generic data application for all the Yahoo properties across the Yahoo worldwide. So they are very, very unique needs asked by e-commerce users in Taiwan. There's such as, I want to know how many page views and how much unique users are visiting a certain product. That is, such kind of data is difficult for us to provide those data to our global data team, let them to customize the data application, to tailor the data platform for us, so that our end user cannot retrieve such information from the global data applications. So that's why we have a dedicated data team in Yahoo e-commerce Taiwan. And we are facing a lot of, in Yahoo e-commerce Taiwan, we have a lot of different type of users. The first one is our general manager or probably business unit heads. They are typically want to view the sales among or simple dashboard for sales performance. And the second type is their business analysis. They are typically the crew members of manager's office. They help managers to define long-term strategy of our business. And the third one is marketer or data analysis. These are the most advanced user in Yahoo e-commerce. They define campaign strategies. They using a lot of technology to find what's going on within the e-commerce business. And then category managers, they are managing products, and they define product campaign sales strategy, and even they define pricing strategies. And then our suppliers and sellers in shopping site or in our store market. So each type of those users have different BI needs, have different data needs. So let's break down the different needs in these two angles. The first one is if they are technical users, or do they need analytical functions? Are they business users and they don't need low analytical features for the reports? And the second angle is how detailed the data they want to see. Okay. Typically, the general manager, they want to see the sales performance or the sales trend in a sophisticated format, such as a dashboard, scorecard, and so that they can compare the sales performance in this month or in this week, and compare it to last week or even the last year, so that they can find the sales trend is raising or is the sales is dropping. If the general manager or business unit heads find something wrong with the sales trend, they then will ask business analysts to find out why is that the dropping is happening. And the business analysts will using OLAP actions such as drilling down, data slice and dice, and the data filtering, something like this, to find out what which category is dropping the most and which type of supply is dropping the most. So they are helping managers to find the root cause of the sales trends. And then we have marketers and data analysts here, and they are usually want to see very, very detailed data, such as transactional details. And they sometimes want to, besides the OLAP actions such as drilling down, sometimes they want to use data mining tools, or even they are writing their own SQLs to query the data in relational database or even in our Hadoop grid. And then category managers, and they usually, because they managing products, so they want to see the product, how the product sells. And how their product performs. So they tend to see more detailed data, and then they don't need any sophisticated OLAP actions on the reports. And then then is the supplier and our sellers. They are typically kind of similar to category manager. They concern about their product, so they also need the product details. Okay, here's the challenges we are facing. Let me just use the Taiwan shopping site as an example. So the consumers go to our Yahoo shopping site in Taiwan. They are surfing on the web. They are browsing the products, and they probably made purchase on website. So in terms of data's view, the surfing behavior will be logged by our web server and stored in the web log files, which is a kind of CSV files. And this file will be sent to Yahoo Hadoop group. And if the user made a purchase, so the transactional data will send to the Yahoo shopping site backend ERP system. And in the ERP system, our category manager might want to view some report from this system directly, such as, for example, inventory report. So the ERP team will create a report for them using the ERP data directly, and by probably using programming language such as PHP or ASP.NET to create a report. And for the ERP, those transactional data in ERP system, we collect those data and transform them in our data warehouse or shopping data marts for creating performance reports. And so that category managers, general managers, business unit heads, they can read the performance data from this the performance report from the performance reporting system. And let's back to Yahoo Global Data team. The web behavior log stored in the Hadoop, then our Yahoo Global Data team will, they created a system allow our user to see what's going on page basis, and they can retrieve how many page views, how many unique users, how many navigational clicks in certain page in Yahoo shopping site. So, and sometimes some users, such as marketers, they want to combine sales data and web behaviors data together. So we don't have such platform or tools for them to doing that. So they have to file a report request. We call it a ticket to some engineer. So this engineer will collect all those data for them and then compile those data in a maybe Excel sheet and send back to the user. So in this chart, you probably see there's a lot of problems here. The first problem is from user's view. If I need to see a product's inventory, I have to go to this system and get inventory data. And if I want to see the sales number, I probably can get sales number from here or from here. And then if I need to know what are the traffic of our Yahoo shopping site homepage, and I need to go to this system and grab the data. And if for some reason I need to track some web traffic for certain products, so I need to file a ticket to a engineer. So the engineer can grab the sales data from here, either from here, and then grab traffic data from Hadoop directly. So the user has to compile all those data. They will get a lot of pieces of data and then combine them into a single Excel sheet and then make a beautiful format and set up them and send them to their managers. So it's the user view. It's really time consuming for our end user. Our users starting to complain about this. And so from data team's view, there's a lot of isolated reporting systems and maintained or created by different technologies. There is a SQL Server, there is the Oracle Server, some system using PHP, some system using ASP.NET, and engineer probably will use a Pig script or Hive query script to query the data within the Hadoop grid. And talk about the traffic reports, we need to call a web service API to talk to our traffic reporting system. So that there's a lot of technology in this technical stack. So in Taiwan, we don't have a lot of resource in data team. So we need to figure out a perfect platform to reduce our efforts for doing this on daily basis. So Yahoo Taiwan needs a unified data platform let our user to retrieve data from this platform in easy and in an efficient way. So ideally, we want to provide our user this platform. We have a lot of data sources. We have three different EC properties, and they generate a lot of data. So we need a unified data process system or data process tool. So we choose a public ETL tools here, and then store and transform and store those data in data storage layer. Now we use Oracle and Hadoop grid. And then we build a business intelligence platform. In this platform, we can create a lot of different business intelligence applications for our end users. Here is where we want to go. Okay, the solutions. We have three different e-commerce properties, auctions, shopping, and store. And for the transactional data, they will send back to their own backend systems, such as auction backend database or shopping ERP system. And we have a unified ETL process tool to collect all those data and then store in our Oracle rack by different purposes. Say we have a sales data mart, revenue data mart, listing data mart, member data marts. And this block is a traditional BI technology stack. I believe that all of you know this already. And the second part is there's a lot of instrumentation in our e-commerce properties. Every single click made by our end users on our website will be sent to our beacon server and then go through a Yahoo data highway and processed by FETL process and stored in Yahoo grid. And there's a lot of information here, such as page views information, click event information, and session information that's processed by our global data team. And sometimes we need to do some data exchange between these two systems. For example, we sometimes send sales data into Yahoo grid, and sometimes we'll collect page views, unique user numbers into our Oracle rack for easy to analyze. And then now we choose a BI platform here, and this BI platform has a SQL engine which can access Oracle rack directly, which will generate SQL script to retrieve data from the Oracle. And it also could connect to Yahoo grid by the Hive server. So by using this platform, user can use this a single web user interface to retrieve all the data either in Oracle rack or Yahoo grid. From end users' view, they are transparent. They don't know where the data is coming from. Okay, let's focus on this part. Traditionally, we have Oracle rack, which is a relational database. And in this platform, we have a OLAP SQL engine and we have a unified user interface here. So we do this a lot, that user can access the report, and then the engine will retrieve data from Oracle Rack and format as a grid report for the end users, or we can pre-process the data in the Oracle Rack to be a cube in memory, so that the report performance can be increased significantly. And now we are trying to add Yahoo Grid into this architecture. So ideally, we want this platform can access Yahoo data, the data in Yahoo Grid, or we want this platform can process the data and store a data cube in memory, so that we can provide faster performance for our end users. And sometimes we want to combine these two kinds of data in one big cube to provide sales data and web traffic data together for our end users. So we believe that using this architecture that we can create a lot of different analytical reports, such as a general OLAP report, scorecard, dashboard, or notification email for different type of our end users. Okay, so the end users only need to learn one single web user interfaces and retrieve the data we create for them, or they can create data on their own on this platform. Okay, although we have idea about this architecture, so we don't know if this architecture or this platform can fulfill or can handle our request. So we did a performance test in the Q4 last year. And so by using visitor distribution by demographic and their device preference, here's the cube definition. We have 7 dimensions and 1 matrix here. And we pushed 60 days web log into the system. It's totally 293 terabytes, the source data, and transformed the data into a big cube, which is a 2.3 gigabytes, roughly 60 million rows. And here's the platform we are used for the test. We have a BI platform server in 2 gigabytes, 2.5 giga with 16 giga RAMs. And we're using Hive server version 0.9 with 4 cores. And we have our Hadoop clusters, roughly over 300 nodes in this cluster. So, and based on this cube, we create 5 different use test cases, which are commonly used by our end users. The case 1 is the generic cross-tab report by birth year and their gender, and slice the data by report date. And the second case is the dynamic prompt on date, which is a predefined ad hoc query report that user can pick any date they want to, and then system will generate the report on the specific date. And the third is a dynamic data grouping. You see that there's 4 different browsers. We dynamic grouping them together. The browser 1 means the IE series, IE6, IE7, IE9, IE10, etc. The second one is Firefox series, and the third one is Chrome and the others. So those data grouping is not pre-calculated in database layer. They are calculated on the runtime. So the first test case is typically 80-20 analysis. What are the top 20 mobile make brands in our users? Okay, and the last test case is based on the case 3 and plus make charting. Okay, here's the test result. We are wondering that if given how many concurrent users, if the data volume impact the system performance. So let's check if we pushed the stress to the platform in 10 concurrent users, 25, 50, and 100. And we generate the cube start from 20 days data, 40 days data, and 6 days data. And let's focus on the 50 concurrent user here, and with the 6 days data. There's the average response time is 19 seconds, roughly 19 seconds, which kind of acceptable to our end users. And the 50 concurrent user is roughly equal to 500 end users in our system. So it is typically a scenario in Yahoo e-commerce Taiwan. So you can see that the average response time is growth in linear, which kind of acceptable, but we are not so satisfied with that. So we are going to make it better in next quarter. And so the next is the average response time by different concurrent users. So we want to know, given a specific amount of the data, if the concurrent user, how the concurrent user increase will impact the system performance. So here you can see that there is a slightly the slope here. We are interested in why the system goes, the performance goes so badly when the concurrent user increases. So we check with the product provider, which is MicroStrategy provider. So there is their limitation. They have 15 concurrent job threads. When we push too many jobs into the system, they run 15 jobs at the same time. So fortunately, we can add more servers to fix this problem. So we can add more BI platform servers and let them to, they can do the load balancing and job rotating between servers. So let me just give you a quick demonstration. In this demonstration, I will cover these three topics. The first one is dynamic OLAP analysis using the in-memory cubes, and how we can use this platform to direct access the data within Yahoo Hadoop grid, and how this platform provides our e-commerce end user as a self-service business intelligence platform. Okay. Let me just switch this there. Okay, here is the web user interface of this platform. So I'm logging. Can I make it smaller? Okay. Okay, here I log into the system. Here's the shopping mall sales analysis in this platform, and I open. Well, okay. Now, as a general manager, they probably want to see beautiful dashboards for revenue data. So we created for them. Let's go to share reports, and there's a dashboard called monthly sales dashboard. Okay, by using this dashboard, the general manager can browse all different category product teams here, and how they perform in terms of revenue. This month's revenue compared to last month, compared to last year, how many items sold, how many unique buyers in this category, and those data are from those data are from the shopping ERP system data marts. So here they can switch the month if they want. So can switch, the data will change accordingly. And here at the bottom here is the monthly trend over this year, and this is the boutique sales trend here. So general manager can see, oh, I want to see more month here. So maybe smaller. Okay, that's good. Okay, I can browse different window of the time frame, and I can add them to, I can see more time or less of time, and then and switch different product teams here. Say I computers sales trend, and if these are typically general manager is going to do against this dash platform. For example, and then you probably find there's something wrong with the employee benefit the product category, or the manager probably interested in some certain product team. So for example, using computers, I can link. I can either to drill down for detail, or I can do some data filter using these commands. Now I'm going to show you how we to view more data details here. So I can select category details. The system will link me to the other reports which will show me the category details here. So the same way I can switch data using this drop-down slide. And for business analysts, they probably do some more OLAP actions, such as I want to know what's the revenue this month compared to last month. So I add some new columns, and what's the unique buyer is he, and how the revenue compared to maybe last year's here. So I drag to here, and maybe I want to know what are the category contributes to the whole product team. So I can right click on the revenue column and insert a new metric. Say I want to a percent to total over rows. Then those are the percentage means the, sorry, this is in Chinese. The notebook contribute roughly 11% to all computer product teams here. And they also can do sorting, or even they can create their own formula on this report. Okay, if I interested in something more about, say, Acer notebook, so I can right click here to drill down to see more detail. Say I want to know the product details here, so I drill down to products, and now I can see each individual model of the Acer notebook. And maybe now those numbers are sales numbers. Now I want to see probably the page views of the certain numbers. So I can also right click and link to another report, say page conversion. So I can know daily page conversion of this particular product. Okay, let's go back to here. Now, there's another section here. I can switch to category breakdown. So I can see maybe consumer electronics. Here's a digital camera sales here. The color means the average spending for each individual buyer. Okay, so the green means they buy more, they spend more. The red means they spend less in this category, and the box, the size of the box means the revenue in compared to how they contribute to the whole product teams. And the same way I can this is a digital camera, and so I can link to even to see the product detail directly, just like what I do in a couple of seconds ago. So here's typically the report or dashboard our general managers, category manager will see in this system. And for data marketers, or data analysts, they tended to do a lot more advanced queries, such as maybe I want to make a query against the Hadoop Yahoo grid. So the marketers can create a new report. Say I want to start by a blank report. So I want to see what dimension I want to see by product, say product team. So I drag product teams here, and by what date. So I put, say, weekly here. And I want to view the page view and unique user for in this week for each product team. So I put a visitor here. Sorry, should be metrics. And there's a lot of metrics here. I have a unique visitor. Add to grid. And then I want to know page views here. Okay, here, those data are stored in Yahoo Grid directly, without not in our Oracle RAG or in the in-memory cube. So that I can save this report, say my page view report, and I can run newly saved report. At this time, the platform will generate a HiveQL against Yahoo Grid. So it will take some time to run. So I can still do other analytics. So I can add this job to my history list. It will send the job to background. So I can log out or go to grab a coffee and wait some time, and then go back to check the job status. And here you can see that the report is still running here. And for general business users, they can create their own dashboard just like this. They can select sales performance, create report from sales performance cube, and say maybe I want a bar chart here and vertical bar chart. So here's the vertical bar chart. And also I can add some new advanced visualization here. Say I need maybe a grid here. So I can add different angles. Say I don't need a year. I need product team and product group. Say OK. Then add maybe revenue. So I can put this area here. So I can give a wider view here. So using this feature, our general business user can create their own dashboards by using this platform. Okay, here's my demo. Let's go back. Okay, to recap. Now you know that Yahoo e-commerce Taiwan is so unique, and they generate a lot of revenue to Yahoo, so they are so valuable to Yahoo. So we are the data team in e-commerce Taiwan, and we service our e-commerce users in a particular way. And now we provide this platform to our end users, and this platform is going to launch in the next quarter. Okay, that's it. Hope you enjoy my sessions. Thank you. I think I just running out of my time. I have 2 minutes away. So if you have any question, I will stay here for a while. So just come to me. Okay. Thank you.